Hey, it's Ivan from the EV Stock channel here, and welcome back to my interview with Rodney Hooper from RK Equity, covering Tesla's plans to build a lithium hydroxide plant in Austin, Texas, along with getting some more insights on the battery raw material supply chain. As always, all content in this video is simply our opinion only and not financial advice. So let's get into it. Now, I just wanted to ask you about Tesla's plans to build a hydroxide plant in the US, and I was just wondering why you think Tesla did that. Do you think it's just due to lower their costs, or is it more due to them looking out and seeing a potential hydroxide shortage and just positioning themselves in a way where all they would have to do is get spodumene concentrate feedstock and make their own hydroxide, sort of take matters into their own hands?
When Tesla had Battery Day, they said as a whole, they were talking about 3 terawatt hours of demand by 2030. So that takes the hydroxide carbonate debate and throws it into the bin. You're going to need everything you can lay your hands on. And you're going to need to, on every application, use the best suitable product to do it. The thesis is, and what we're saying is, I think that the Semi and the Cybertruck are going to be extremely popular. In my opinion, the Cybertruck is going to have 1 million units of demand by the time the plants open later this year. Now, those are big battery packs going in, and this is why I'm saying if you think the Model Y is doing well in China, I think that the Cybertruck is going to shoot the lights out. And that is going to put an enormous amount of constraint on hydroxide availability globally, because those Cybertruck battery packs are going to be at least 80 kilowatt hours, I would have thought, maybe even 100 for the bigger ones. At the same time that Rivian, the Ford, all of the Hummer, everyone else is planning lineup. So I think Tesla's worked out you can't do this in an inch by inch basis. They are going to need to take matters in their own hands, especially producing the 4680. We think shorter term, Tesla's going to outsell forecasts, and I think Cyber is going to be a crackerjack, and so is the Semi, and those are both high nickel, very high nickel cathode-based batteries.
Yep, and with high nickel, you need hydroxide.
So I see the squeeze. I think longer term, the trouble in carbonate supply is also coming. It's just a matter of time. I just see that Tesla is seeing the competition and aggressively looking to ramp up its production and sales. So for my money's worth, I don't think 1 million units is out the question this year if they can get Berlin and Austin up and running on time.
Yeah.
And there just isn't enough availability, and they see that growth going further and further out, and they see high nickel as central to their specialist applications. So that means they need hydroxide. So they're going to tackle that first, because in the US, the Semi and the Cyber is what they're going to deliver. So I think that is the reasoning for it, but I think that in time, they will need solutions for carbonate, they'll need solutions for everything if they even vaguely reach their goals. It's just, in Europe, they could possibly sell some of the short-range Model 3s that use LFP and so on, so you can, they're servicing Europe to some extent out of China for now. We'll see how that evolves. But, whether or not as well, saying they're going to produce hydroxide in Texas at a plant is a gaming strategy with negotiating. I think the truth is it's a very short-term strategy if it is, because if we look at where EV sales are going, and I think 4 million to 4 million plus is doable this year, gaming companies to sell you a bit cheaper it's not going to help when everyone's in full flight.
Yeah, so you were talking about this when you did your interview with Galileo from Hyperchange, and you were talking about the Mexican standoff that was taking place between the OEMs and the lithium producers. How do you see that playing out if the lithium producers...
We've seen the first play out, and that is that Tesla's now signed with Yawa. We were already at 80% of battery-grade hydroxide being produced in China, and now it's going to be even more. But again, great. So you've bought yourself some of the supply, but we're seeing demand go above it. You cannot avoid, negotiating with Albemarle and whoever else in the end, in the Mexican standoff. So
Yep.
Logically, you're going to buy from the cheapest guy first on the proviso that the quality is acceptable. Because, your reputation is once. And if there is a problem with any of these battery packs coming from this supply chain, because you've rushed through the qualification of a new supplier, and you're going to have a problem. Well, aside from the fact that if you have to start replacing battery packs, you've got a cost problem. It is a risk to rush through a new supplier. I don't want to be unfair to Yawa. They've been around, but I'd like to know what was qualified and what material they'll use in the future and how strict the qualification of that process will be. But they definitely have some skills in-house. They are needed, but I don't think that I think that just pushes the Mexican standoff for how long? Look at the demand for Model Y in China. What are you going to do when Berlin and Austin are fully up and running? Supposedly by around the middle of this year or starting to produce.
So how's that going to play out? Because you're saying that a lot of these lithium companies are starting to constrict supply to push the price up to a level where they feel comfortable selling it and having enough margin to then be able to reinvest and expand production. I mean, wouldn't it make sense for a company now to expand production now, so as the prices or if the prices go up, they'll be, really well established to capitalize on that?
Chinese companies have done that because their capex to build hydroxide capacity is much lower than the rest of the world. So it costs $5,000 a ton or maybe a bit more to put up, capacity, whereas in the Western world, it's $20,000 to $25,000 a ton. So the risks aren't the same. If you're in China, it's a lot lower to spend the 5 than the 25. And Albemarle is quite clear. They say that the economics needs to be there. They want 2 times WACC, which is weighted average cost of capital. So even with interest rates having fallen, I would wager that they still need at least 15 to 17% as an after-tax IRR to pull the trigger to build a new plant. And unless they have suppliers lined up with long-term contracts, they don't build. That's their formula. So the speculative people are the Chinese. They will do it. Ganfeng or whatever, you running at less risk. And, and Yawa and a couple of others are also, Yuvintanyi, they're also having a go. So, they're riding less cash, but, meeting requirements and meeting spec and honoring contracts and doing all of those things, is a different perspective. But what I'm saying to you is by the second half of this year, if Tesla does as well as I think it is, and some of the other OEMs, I don't want to just go Tesla, but, they are doing extremely well. We'll see on the other OEMs how well they sell. You've also got all of the new battery cell plants coming on stream in 2022, which means that they will need to pre-order their cathode in 2021. I think, assuming they're going to start early in 22, they're going to need to order it in the second half of this year. And I'm aware of a number of those battery cell plants that haven't sorted out their procurement yet. So it's going to get interesting because, as I say, I think Western OEMs don't have a choice but to sell EVs. Otherwise, they've got to pay hefty penalties. Or you've got to pay someone like Tesla to to sell you the credits or join a grouping like that. And Tesla has a market cap of $700 billion. They need to move the metal now, in order to justify that valuation. So I think, they've got the big casting machine. They've got everything lined up. They've got the 4680 coming in. I think, they want to, and I think almost to a point they need to, with their valuation, exceed every supply estimate out there.
And what does this mean for the other auto OEMs? I mean, if hydroxide prices, start going up, if demand is being constrained, they then have to transition to electric vehicles at a time where hydroxide prices are going up. All of a sudden, their margins get squeezed.
The risks are there, and you've hit the nail on the head, and I've said this before, and I said it on the Galley interview. If you want long-term pack prices in the $60 to $80 per kilowatt hour, you have to control the cost of the battery raw materials. There is no way around it. So you've got an unavoidable demand for hydroxide coming up. Those numbers that you quoted earlier that I've done in the past, I think those are conservative. I think
Mm.
Suddenly EVs are, popular. People want them, and demand is on the rise. And it always was going to happen because model choice gives you demand. What you will find is that the OEMs that haven't secured it are going to, how much can they squeeze out the battery cell manufacturers and how much can't they? Because cathode manufacturers effectively are almost tollers these days. They just take everything in and ship it out for a margin. They don't do it at risk, most of them, I don't think. They just, Tesla, whoever has bought already their material, they ship it to you, or they just pass on the price. So will the battery cell manufacturers lower their margins because they're doing bigger volumes? I don't know. VW has negotiated some of that going forward, and that's why you see people like LG having long-term contracts with SQM and with Ganfeng and what have you, because they can't take the risk on some of their production. In Tesla's case, I guess Tesla probably came to them and said, we need more, and they said, great, well, and Tesla then had to provide the hydroxide, which is what they've done with Yawa to limit, the price moves. But you've hit the nail on the head. I think there are quite a few OEMs. JVing in a cell plant doesn't limit your raw material costs. It just helps you lower your battery manufacturing costs, but not the input costs. So I think there's problems coming for some of them.
And just on a final point, when it comes to nickel, what do you think Tesla's doing to secure their nickel supply?
Good question. Now, bear in mind that nickel has a pretty decent futures curve, so you can buy forward. And you could, in the old production methodology, you take the briquettes or what have you from the LME, that gets 99.8, that gets to completely pure for sulfate. So they may well have hedged some of that, but I think they are looking to secure further back upstream concentrate, etc., where they can deploy their alternate flow sheet that they showed on Battery Day in order to make a precursor for the cell with far less hydromet steps and what have you, instead of having smelter, refiner, and all the rest. I think they're looking to skip out a few steps, have a sulfate free, I think they mentioned. I stand corrected, and I guess lower cost.
Yeah.
How are they going to secure that? Well, I think, it's no secret they're talking to everyone. They're also Indonesia. Don't forget that. Yep. I think there's a very real chance that they're going to set up shop in Indonesia along with LG and CATL.
Yeah, because I've heard in the past, Indonesia has sort of reduced exports of nickel. So I'm just wondering if that's still a risk.
They were reduced of the nickel ore, so they wanted the beneficiation to be done in Indonesia. So rather than ship low-value, high-volume material to China to be processed, they put in a requirement. In this instance, it actually plays in well, because if you're having downstream processing done in Indonesia, then you are able to supply Tesla, LG, CATL, etc., with potentially a far more refined product in order to be used then directly in a battery. Okay. Now let's think about it. So there are lots of things that go into a battery, and Elon's mentioned a battery is actually a nickel graphite. They shouldn't call it lithium ion, they should call it nickel graphite in terms of volume, but in terms of value, if you go down the value chain, nickel, as far as the cathode is concerned, on a high nickel chemistry is about 45% of the cost, and lithium about half that. So though, if you take it that the cathode is a large portion of the cost of a cell, it's like about half, and then there's production, processing, etc., then you get to realize how important it is to control the nickel cost and how important it is to control the lithium cost.
Mm.
And I guess, graphite comes next after that. And again, the thing is, you've got to look, something like graphite, and it's to Jordan's good question, is graphite is a lower percentage of the battery raw materials cost than nickel and lithium. But if it is made in a very carbon intensive way, it can add a very much disproportionate amount of the total carbon emissions in the construction of the anode versus its cost. So there is definitely merit in projects around the world that are looking to do carbon neutral graphite production, because it won't necessarily add materially to the battery cost, but it'll lower your carbon emissions, and that's important. And it's going to become increasingly important.
Perfect. All right, maybe we'll end it there. I mean, that was, a lot of information that we covered throughout this interview. So thanks again for, being on the show and sharing your wisdom on these topics. And I hope we can talk soon.
Good stuff. Thanks very much, Arvin.
So I hope you guys enjoyed that interview, and let me know in the comments what your thoughts are. So until next time, I'll see you guys soon.